Page 16 of this packet looks like this. Find the intersection. That means where do they overlap? What do they have in common? This one has a 1, this one has a 1. So in the intersection, 1. 3, 3. I'm 2 for 2. 5, 5. 7, this one doesn't have a 7, so it's not in the overlappage. 9, this one doesn't have a 9, so 9 is not in the overlappage. The intersection of those two sets is just 1, 3, 5. So far, so good? Remember the empty set, you can rewrite the empty set just like this. Is 2 in there? Nope. Is 4 in there? How about 6? Nope, nothing's in there. So what's the intersection of 2, 4, 6 with the empty set? The empty set again, or the empty set. Find each union. Union's nice because you write it down, and you keep it all. Write it, keep it. Here it goes. And then you want to rearrange them in numerical order, but Pearson doesn't care. 1, 3, 5, 7, 9, 1, but I've already written it. 2, 3, already there. 5, already there. 4, and 6. Write it down, keep them all. Everything that's a part of the original two sets is going to be a part of their union. So, union looks like the letter U. We could replace it with or. Okay? Write it down, 2, 4, 6. Then write down every element that lives in the empty set. And you are done with the union. So the difference between the intersection and the union, keep only where they overlap. This means and. Union means or. Keep everything. How about subtraction of two sets? We're going to start with A. Remember, subtraction is not commutative. A is the set minus B is the set and start subtracting. A minus, nothing cancels. B minus, nothing cancels. C minus, okay, those C's are gone. E minus, okay, those E's are gone. H minus, and then the difference is everything that's left over from the original set. That is their difference. Every element that lives in A that does not live in B. Oh! And H. Uh-oh. A, B, H. Don't forget your H. I lost it. Is that better? Anybody have any questions on that? Let's subtract B minus A. So subtracting A from B, we start with B, C. We start with C, E, and G, and we're subtracting from it A. C minus this stuff over, gone. E minus, oh, they're gone. G minus, so the difference between B minus A is just G. So now we have the set that just includes G. We want to union that with not C. Union means write everything in this, write everything in this, and keep it all. So now we have to write everything that is in the universal set that is not in C. Not in C is A. It's in there already. B. It must be in not C. C. It's in there already. D, it's in there already. E, it's in there. F, it's not in there. G, it's in there. H, it's not in there. So not C, or the complement of C includes B, F, and H. So we write them all down, and keep them all, B, F, and H. How are you guys at that? Is that okay? Let's take the Cartesian or the cross product of two. Remember, the cross product of two is a combination. It's going to build a bunch of ordered pairs. So A from the first set is going to pair off with each of the elements from B. So the cross of A and B, or the Cartesian product, is the set of ordered pairs. A pairs with 1, A pairs with 2, A pairs with, yeah, we do. Because each one of these ordered pairs is an individual element. Then it's kind of like distribution. B goes with 1, 2, and 3. B goes with 1. B goes with 2. B goes with 3. I like to make ordered pairs. How many ordered pairs did we just build? 1, 2, 3, 4, 5, 6. Remember, the number of elements that live in a Cartesian product equals the number of elements in A times the number of elements in B. And multiplication of integers is commutative, so it should work both ways. 2 elements here, 2 times 3 elements there, 3 equals 6. Good system of checks and balances to make sure you've got enough. Let's cross B with itself. So we're going to cross 1, 2, 3 with 1, 2, 3. There are 3 elements in B. There's 3 elements in B. How many ordered pairs can we expect to get? 9, here it goes. We're going to pair up. 1 pairs with itself, 2 and 3. 1, 1, 1. Boom, boom, boom. We're 1/3 done. 2 pairs up with 1 itself and 3. 3 pairs up with 1, 2, and itself. They're ordered pairs, they're ordered pairs, they're ordered pairs. Each ordered pair is distinct from the next, and we separate them all with commas. Are there 9 of them? 3, 6, 9? I feel pretty comfortable that I got them all. And that's how the Cartesian product works. Last problem. The number of terms in A is 12. The number of terms in B is 7. Then how many terms are in A cross B, and then how many terms are in B cross A? So we just take 12 times 7. Or we take 7 times 12. And get 84. This problem is exactly identical to that bat or vampire problem, but this one's a little bit different. Let's do this one together. A circle, B circle. Call one A, call one B. And now, let's shade lightly everything that's not in A, everything but the A circle. That's everything but the A circle. Now we shade lightly everything in the B circle, and I'm going to shade this way this time. And I only want to keep where their shadings overlap. and at the same time. So what's not in A and at the same time is in B. Can you see that region? Did we do this one already? Not in A and in the same time has to be in B is everything that's black. Go back and erase the rest. If it was union, you no need to erase, you just keep it all. But intersection, you got to shade it lightly, and keep only where they overlap.